Hey guys, welcome back. So today we got a 2016 Hyundai Sonata 2-liter turbo. Customer complained engine shaking, vibration, and as for the advisor, they just replaced 4 spark plugs on this one and an ignition coil. So let's scan for codes for now. I'm just gonna go straight to the engine side and see what we have here. And also, he's complaining also on excessive engine oil consumption. So I don't know if those two complaints are related. So we got cylinder 4 misfire and a vent circuit control open. So this vent and control, that's for the evap system, and that's for our canister close valve. So I'm not gonna worry about that for now. Let's go to our freeze frame for P0304. When I got this car from the parking lot, it was shaking. So I'm just gonna see here what we have. Vehicle speed at 2 kilometers per hour. Short term, bank one, 17%. So it's reading lean. So it's adding fuel. Oxygen sensor adaptation. It's at minus 17. So it's reading too much fuel. Okay. Let's go home and let's go data analysis. And let's just confirm if it's really cylinder number 4 that's misfiring. And let's maybe graph our oxygen sensor too. And our, what else? Lambda correction. So upstream, downstream. Get our lambda correction here. So actual lambda correction and misfire counters here. Okay, let's graph that. So we got oxygen sensors, lambda, and 1, 2, 3, 4 misfire counters. So let me start this vehicle. Okay, so number 4 is misfiring. If I'm gonna raise the RPM, does it improve? No, doesn't improve. Lambda correction is around less than 5%. Downstream auto sensor is 0.9 volts. Okay, so lambda correction now it goes down now, minus 8%, and we still have a misfire on our cylinder number 4. I wonder how rich is this running. So number 4 is misfiring. I'm gonna go to our short-term fuel trims on LBD2 side, because on the manufacturer side they call that fuel adaptation, right? But I'm more familiar reading a short-term fuel trim. So let's see here what we have. Short-term fuel trim here, long-term. So minus 2%. Oxygen sensor. Got this downstream and our upstream. Okay. I wonder if we have a dead hole on this one. Okay, so long term goes up to 15%, 17%. My short term is reading minus 1%, so not that bad. I was thinking it could be an open injector, and I don't have any telltale sign that my exhaust fumes there at the back, it has excessive smoke. So I think we're dealing something here with mechanical. if I'm not mistaken. Maybe. So what can we do next? So since we did replace already, um, what do you call that, spark plug, ignition coil, I think the best way is, let's just rule out if there's a mechanical issue here or a different issue, right? So one way you can do is you can do a compression test, compare. Let me just shut this off. You can compare each cylinder with compression mechanical gauge, right? Compare each one, and or you can do a, they call it relative compression test. With that one, you're gonna be using a scope and see um, the compression in each cylinder, which one is down or which one, if they have an even compression contribution, right? So I think let's do that before I remove everything there. I know this is four cylinder, it's a quick one, but let's do a relative compression and see our reading there. All right, guys, so I'm done with my setting up of my probes, right? For our blue trace, that's our high current clamp, right? So I just went to the negative cable. Our red will be our cylinder number one. That's our reference. Since I have multiple channels, we can do also engine running later and see and compare cylinder number one to our suspected cylinder number four, right? That's our green channel. So to do a relative compression, you have to disable the engine to make it run. So the only thing, the best way is, because since we're gonna use our ignition um, sink here for reference, we're gonna remove our injectors, right? Or we can remove a fuse or something like that. So since this is accessible, it's easier. I remove our big connector here for our direct injector. So let's go inside the car and let's set up our laptop. Okay, so if some of you guys don't know what's a relative compression, it's a quick way to do see the contribution of each cylinder and compare each one, right? You don't know what really is the pressure in there, but relatively you're just comparing each cylinder if all they're the same, right? We use our negative cable from the battery to measure that. You can also do the positive, but whatever works, because you're just measuring the current flow from the starter, because every time it push up to the compression, that's where the greater load from the starter gets, right? So that's why we're doing that. So our amp clamp, I because I think that's 1 millivolt per 1 amp, so I did 1 volt here per division. Our um, reference or the ignition sink, I use a relay there to get a waveform for that, right? You can also, if you have a wiring diagram, you can look for that ignition trigger, because it's a 3-wire coil, so it's not 2-wire, that you can choose one for the primary side, switching side for the ignition call to fire. So this one is 3-wire. You look for the trigger to make the ignition call fire, right? So anyway, we're gonna try to run this. So usually with relative compression, I like to run it from 1 second per division or two. So, and with a picoscope, it doesn't matter how long you put the time base wise, because you can always zoom in. So I'm gonna put 2 seconds per division here, and we just have to crank this car. I can hear, looks like the engine rotation is so healthy for me, the way I can hear it. So let me stop this capture, and then let's zoom in and let's just see what we have. So earlier what I said, cylinder number one is the red trace here. The cylinder number four is the green, right? And as you can see on our blue trace, if you follow my mouse, that they're all even, right? As you can see that, you can see on my, let's zoom in more here. So, and then I'm gonna put the, what do you call that? A cursor here and divide it in four because we have four cylinders here. Okay. Now, you have to know the firing order of your vehicle too, of the engine. In this case, Honda uses, if it's a four-cylinder, 1342. So this is my cylinder number one here. If you follow my mouse, number three, number four, and number two. And you can see there, let me clean this up a little bit because there's so much noise. Okay, something like that. And you can see that they're pretty even, right? One, three, four, two. So in that case, and also by hearing it when I was cranking it, it's a little bit, not a little bit, but it looks they're even. Because if there's a hole or there's one cylinder that's not contributing, you can hear it different sound, right? So now, at least we, on this case, we proved something that for now, all four cylinders are contributing the same, right? We don't know how really is number four to compare number one, but on this relative compression, we see that they're all the same. So we're gonna move on to the next test. Um, since I hook up my secondary relay to check the ignition, we can compare cylinder number one and number four, since our cylinder number four is a suspected cylinder for a misfire. So let me remove my amp clamp there in the negative cable, and we're gonna run it again for um, engine running, right? Okay, so since I removed the higher amp clamp, so I replaced it with the smaller amp clamp, and then I removed the coil, ignition coil, amp probe, or the fuse. I'm talking about the fuse. And we can see also the ignition coil ramp, right? The current ramp. So let me start this vehicle. So you can see there that we can get some um, pattern right now. So let me stop it, stop the vehicle, and let's just compare. So cylinder number one, red, right? Let me separate this. My green is cylinder number four, right? So the same thing. Follow my mouse. One, three, four, two. So far, ignition coil, you have the same ramp compared with the others. I think I turn on my filter again. Yeah, okay. So you can see there, same thing. So I don't think we have an issue or ignition coil, but on my spark plug or the secondary waveform compared to cylinder number one, let me just go zoom in here. So that's our cylinder number one, and this is cylinder number four. Where I can see on number four compared to number one, it looks like I have an issue with my secondary. So it could be in the spark plug. The coil fires, right? No problem. But I don't have this. If you follow my mouse like that, and it goes up, this guy on number four just went down. That's it. Nothing happens. Oops. So, but my ignition coil ramp there, and see that? I think that's all the same on number 4. Yeah, the same number 4. Number 1, there we go, number 1 there. And look at our coil, they're all even. The amperage, right? This is 100 millivolts per 1 amp. No, 1 amp per 100 millivolts. Yeah, 1 amp per 100 millivolts. So this one is reading around 300 millivolts. So this is 3 amp. Right now, that's running in the form, the, what do you call that? The way it looks like, right? Here, the curve and everything. 1, 3, and number 4. So looks like, I think I'm gonna go remove that spark plug on number 4 and see what's going on there. But they said they already replaced this number, all the spark plug. But let's see. This looks like I'm thinking in that area, spark plug or the secondary on that ignition. So let's remove our spark plug here. Okay, so let's remove our number 4 ignition coil. Okay, and remove this connector. And with that current ramp of our ignition coil, we see that they're all the same. So we already ruled out that electrically, we're okay with that. Power ground and the trigger. Our ignition coil there, brand new. So now I just want to see if what's going on with this spark plug. And he has also a oil consumption issue. Maybe we have a oil consumption on that cylinder and then causing our spark plug to get fouled. Yeah, look at that. That's not good. So that's why it's not firing. Look at that. That's fouled. That's with fluid there. So I'm gonna remove our cylinder number 1 just to compare. Let's see how dry is this. Okay, so kind of hot a little bit. Here's our number 1. You don't see any fluid there. Here's our number 4. You can see that that's dark. And you see that shiny part there? That's the fluid. So, what do we have here? And we know that in our short-term fuel trims, we don't have any negative reading there. So I don't think we have an injector open, right? Causing for this. And it looks like it smells oil. So what I'm gonna do next is I'm gonna put in a Borescope there, a camera, and let's see what we have inside. I hope our piston is all the way at the bottom, dead center, so we can see clearly what we have. So I'm just setting up my Borescope here. Okay, here's my Borescope. I'm using my phone with the accessory. So I'm going in. Oh my god. So that's a lot of fluid there. Okay, I have to turn the engine. I have to turn the engine first. So Let me turn the engine and then we can go inside again. So here's our, I turn over the engine. Um, I'm going in now, right? I did ignition on just to see if we have an open injector. Here, so that's all fluid there. And I don't think that's a, see that? Well, that's the reflection of the piston on the cylinder walls. Now look at that there. So I guess that's why he's complaining about excessive oil consumption. You can see the edge of that and the edge on the other side of the piston. Let's flip this camera and see our valves. And you can see, oh my god, look at how ugly is that. All carbon buildup in the valve face. Especially this guy, look at that. And I don't think that's fuel. So, okay, I guess this is the end of our our diagnosis. I'm gonna go into our cylinder number one just to compare that cylinder. You can see that clearly. That's dry, right? The edge of the piston, you see that, right? Unlike the other one, how about the face of the valve? Look at that, it's so clean, right? Unlike on our cylinder number four, what they say when I was watching one of the clips on one of the engine rebuilder, you can tell that you got some oil consumption issue or cylinder wash. That on the edge of that piston, it's cleaner, shinier compared to the rust, like compared to this guy here and to that guy. So we got some issue there, and this is clearly an oil consumption issue, not an fuel. I don't think fuel can make like that, in my opinion. And the customer was saying that when they replaced this spark plug, everything went fine, and then it happened again, right? So this one needs an engine. So I have to submit all this documentation, these pictures, because it's either they're gonna give me or approve for a new short block, because that's a bottom end issue, send the head out for cleaning, or they're gonna give me the whole long block engine. So I'm just gonna replace this with a used one. I'm gonna look for a used one and let's check for sure. We will have no misfire for a while, and then it's gonna misfire again. So let me set that up. I'm gonna put everything back together and see. Alright guys, so I put everything back together. My scope leads still hooked up. I just replaced the cylinder number 4 with a used spark plug I have. So let's start this car. And I don't feel any shaking or misfiring. And we can see on our data here, they're all 0, right? Now on my scope capture, let me stop this. Let me just turn this off. And let's go in again. Oops. Number 4 and number 1. And you can see here, oops. This is on my number 1, as you can see there. After it fires, you still have that kick at the end, right? I know my secondary testing leads for this one is not great. I'm just using a really different. There's other equipments there that you can use to get a nice capture. Here's our number 4, and we can see clearly that there's some energy there, or a kick, or a little bit. Not that great compared to the cylinder number one, since number one has no problem, right? And for sure, maybe that oil there on cylinder number four is still getting in there. Number one, you can see there. That's nice. Number one, number four here. And if I'm gonna open my capture earlier, and we can compare it. Let's just see here quick, okay? For sure, we got an issue with that. Cylinder number four, that's all consumption. Needs an engine, unfortunately. Number 2016. I'll go 2016. I put the 2016 Sonata. Okay, here, six Sonata. Close this. Okay, here's our number one. Oh, number four, the green. The same thing on our current capture. And you can see there, if you follow my mouse, turns on, fire, but nothing happens in this side here. Nothing happens on this side. Okay, let me move this and let's open our current measurement right now. And as you can see there, clearly there's a big difference on how the spark plug fires, right? This one didn't fire because it's soaked with oil. On our left side, that's our original spark plug, well, the new spark plug that got soaked on oil. On our right side, that's a used spark plug. We didn't have any misfire, but sooner or later it's gonna misfire again because I think there's so much excessive um, oil there on that cylinder for the combustion to occur. So it's gonna foul again on our used spark plug. But in the end, we did our testing here, and it led up to our what really happened on this case, right? So we didn't jump around. We just made sure that we follow our task and lead to our problem on this vehicle. So yeah, I'm gonna put a report on this. Needs an engine to fix this issue because even though how many times you replace that spark plug, it's gonna get fouled, and and just keep replacing that until if you don't want to misfire. But if you want to fix this issue, unfortunately, you need an engine, and it clearly shown our secondary waveform, the before and after, that what really happened there. So yeah, um, I'm gonna. This is the end of the diagnosis, I guess. I don't know if this is gonna be approved. What's the kilometers on this guy? Let's see first. I don't know if it's warranty or not. 191. So I don't know what they're gonna do with this vehicle because I don't think this is warranty. I'm not sure, but yeah. So I'm just gonna end this video here, just diagnosis, and yeah, let's see if we're gonna get an approval for this for an engine to fix this issue. And other than that, I hope you guys enjoyed that testing on what we did to pinpoint on what's really the issue in this vehicle, right? And thanks again for dropping by, watching this video, my previous video, and for subscribing to my channel. Thank you. And see you again next time. Thank you for watching.